Okay, this was the question I did yesterday that I didn't have time to record, so I'm doing it today. So we have the wandering ant, question one. An ant starts at the origin of the plane. At each step, with one probably 1/4, the ant will move 1 unit north, south, east, and or west. What is the probability that the ant returns to the origin before hitting any point on the boundary of the square with vertices at 2, plus minus 2, plus minus 2? Okay, so this question is another like kind of like probability question, and it requires like just not, it's also Markov because it doesn't require like knowing one state doesn't impact knowing the other. Like doesn't care which, we don't care how many moves we did, we just care about at this point in the game, how much do we have? And I kind of drew a kind of box to represent this. So let's zoom into that. So this is the box I have of the 2 times 2 grid, where over here, this is my center. This over here would be my center. And I call my center state code A. And then there's actually kind of th two kind of spots that I really care about. Is this spot over here, which is B, and I have four of these that are symmetrical because it's symmetric around a square, so it doesn't matter where I am at. And then there's the point C over here that are these 4 points. And these are also symmetric, so I don't really care which one is which. But these are kind of like the moves I have. And I just define A, B, and C. So the four moves of A that are possible is just all leads to B, right? No matter which way you go, you lead to B. So A is just equal to B. For B, we can have four moves. One of the moves goes to A, two of the moves go to C, and one of them ends. So I just do 1/4 N, 1/2 C, and 1/4 A. And I do the same with C. So I see there's two of them that leads to B and two of them that ends. So that's why it's 1/2 N and 1/2 B. So these are kind of the states that I have. So then from these three states over here, this, this, and this, I can write my equations. So I know that A is equal to B, A is equal to B because there's nothing over there. And I know that B is equal to 1/2 C plus 1/4. And then the other one should be technically plus 0, but plus 0 doesn't matter. So we can just ignore that. And then the same with C. C is just equal to 1/2 B, and then there's a plus 0 something, which doesn't matter. So then we can just plug in C, substitute that into the B equation, and we get that B is equal to 1/4 B plus 1/4. So then just by simple algebra manipulation, we get that B is equal to 1/3. And then since A is equal to B, then A is equal to 1/3. So the chance of returning back to A is 1/3. And that would be the answer to our question. I'd say this question is relatively easy, but you can see that inside here on my steps, I had to cross out a lot of things because I realized that I misread the question. When it said I have 1/4 chance of going north, south, east, west, my brain didn't process this information and I thought it would be like walking in all directions. So the diagonals would be allowed, but obviously that's not the case. So that's why I had a lot more extra states over here than was needed. So, but the idea, I had the right idea to approach this question. It's just that I messed up yeah, my first answer wasn't correct. So that's why I realized that the diagonals were included. So it's actually important to actually read the question fully before I make any, jump into calculations. Cool, that's enough here.